ever struggled to quickly find specific data within a vast data warehouse? What if you could leverage the power of AI to create a user-friendly, natural language search interface to navigate an immense sea of information? Join us as we tackle this challenging problem with a simple solution. We'll be harnessing the power of Google Cloud technologies, but we'll underline principles that you can carry over to other environments. Buckle up as we jump into a fresh project and bring some data into our BigQuery environment. For an interesting example dataset, we'll turn to the Public Datasets program. We'll proceed with this public dataset, which houses information about scientific papers, specifically from the realm of biomedical research. Upon inspection, we notice things like titles, paper abstracts, and links. A multitude of journals are represented here, making the data quite abundant. We're dealing with tables that are sizable within the gigabyte range, raising the stakes of our adventure. Now, this treasure trove of data resides in a public datasets project. Our journey requires us to clone this into our project. So let's forge ahead by copying the data in our first tab here. Keep in mind, as the warning suggests, we need to fire up the API to enable the data transfer. Let's turn on that API now. Once we refresh the page, after enabling the API, we can kick off our transfer job. Here's the plan. We'll choose the dataset copy option and run this operation on demand. We'll need to snatch that source dataset ID for the copy operation. Let's set the transfer into motion, and in no time, we should have our dataset copy completed. Guess what awaits us in our BigQuery studio? The shiny new dataset cradling all that data. Are you ready for the next phase of our journey? Let's sculpt the search experience atop this. We're enlisting Vertex AI as our trusted ally for this task. To illuminate the concept before diving in, picture this. We have our BigQuery instance housing our data, and above it, we'll be placing Vertex AI Search. This is a turnkey service integration, so we won't need any custom integration work or code. Let's migrate over to the Vertex AI page. As this is a new project, we need to enable all the recommended APIs. Then, we'll stop by the Vertex AI Search and Conversation service. Here, we'll get to choose the blueprint for our first app, where our focus will be on sculpting a search experience. Picking the data store will lead us to our BigQuery table, and we'll be taking advantage of this data in a structured format. Now comes the moment of truth. Let's click to create. The indexing can normally take some time, but we only have around 71 records in this table, so it was a fast import. Let's cross-check to confirm that our raw dataset matches. Sure enough, perfect match. To highlight using multiple tables in the AI search experience, let's add another, this time larger, table. the Nature table comes to mind. Let's dive in and explore. In this dataset, we have the entire body of the articles at about 100,000 records. This table looks great for showcasing our AI search, so let's repeat our Vertex AI Search app creation process with this table as well. While it will take at least a few minutes more than the first table, once it's done, we have an impressive dataset of around 100,000 records. Looks like we stumbled upon some errors when importing this ocean of data, which affected the import of 4 records. It looks like the body of the paper for these 4 cases was too large. So we're missing 4 research papers out of about 120,000, but we'll let that slide. A fun break from our setup, we can check out a search sneak peek right here in the console. Ask the AI to show you some intriguing research about water, and voila! You have some papers popping up about surface water, environmental chemistry, and even freshwater ecology. See? That's the magic of AI, capable of bringing water-themed research to your fingertips. Remember, all these results are compiled with advanced AI semantic search technology rather than primitive keyword or facet-based systems. One downside, though, these results are a tad bit difficult to read. Also, we may have search users that are not comfortable with the Google Cloud Console. Fear not, we're about to up-level this app by creating a simple, low-code custom interface over it. This not only overcomes the clunky formatting, but also allows us to search across multiple tables for the ArXiv papers and Nature papers, all within a single app. For this app, we'll be using Streamlit and this API-based integration. A quick conceptual overview. We're envisioning a Python-based Streamlit app integrated with our Vertex AI Search service. This service can, and will, span multiple AI search APIs, giving us capabilities across multiple disparate data stores. Ready to give it a go? Alright, it might look like we're pasting in a ton of code here, but don't fret, we'll walk you through the whole thing. The good news? We have just under 100 lines for a full-fledged app, covering both the front end and back end. To get this running, we'll need to install some modules like Streamlit and Pandas. Let's kickstart installations while we dive into the code. First things first, this API needs authentication and specifically Google Cloud authentication for calling our AI search APIs. Thankfully, the Cloud Shell environment auto-authenticates with the logged-in user, so half the work is done for us right there. Now, we have our API URL, make post calls, and as required, a page token is provided to paginate through the results. Once we aggregate these results, they are returned as a consolidated structure. To display our results across these varied search apps, we'll set up a function that renders our results nicely with a header and a table. This data is broken down or flattened by the Pandas module to allow for a clean representation in tabular form. Now we're at the heart of it, the main body of the script. It holds the title and covers prompting the user for a search query. Once the user keys in the search query, we use that query in calls to both AI endpoints. These endpoints are what we see here in the console. We fetch results from both the Nature and ArXiv publications. For many IDE environments, you can test drive from here. The code successfully runs, and we can pop a web preview and navigate to port 8501 to try and see what we've created. But don't get your hopes up. Our app won't load here because we need WebSocket capabilities, which is not available in this Cloud Shell environment. That's an excellent excuse, though, to conjure up a Docker container to properly run this application in a production-grade way on Cloud Run. To make sure our service runs smoothly, we'll need some Python modules. Our Docker file is pretty simple and builds on a standard Python base image. We'll opt for the Python 3.9 Slim image and install our modules with pip. Let's not forget to open the portal to this app, in our case, port 8501. If you need some environment variables for your app, you would add them like this. To run our service on Cloud Run, we need to push our image to a repository. An easy way to do that is by using Docker Hub. However, since we're already in Google Cloud, why not use Docker Repository here? Once you've lit up that Docker repository, the helper command will adapt your terminal to use that repository for pushing. Then we can build and push our image. We're all set. The time has come to unveil our enchanting app. Again, check the video description for all code if you're following along. Let's head to the Cloud Run service and set our service into motion. For demonstration's sake, we're going to have a single instance at all times. If you're feeling adventurous, you could also play with auto-scaling. Since we've kept things stateless, auto-scaling should be fairly straightforward. For some use cases, you might need the turnkey authentication layer. But in any case, we're going to need to change the port that we're running on. Everything looks ready, so let's cast the spell and bring our creation to life. A successful deployment is always a good sign. Now let's test our creation. We're getting a 403 forbidden error because of that authentication layer. Instead of being caught up in complex authentication work, we'll simply demonstrate open access. It looks like we can't change this setting and need to create a new service. With that set, we're ready for our AI search experience. It seems like we have some results from both of our AI search APIs. Let's expand this view a bit to see the full 21 results. You can further interact with this data, like by exporting CSVs. Remember that we can do this multi-data source results aggregation and potentially even results blending across a variety of data source types. In Vertex AI Search and Conversation, use your treasure troves of website data, unstructured documents, or even APIs. Join these diverse data sources in an app, as we've shown today, for a versatile and powerful AI search experience. As a part of our AI tutorial series, for every 10 new subscribers to this video, we'll donate $1 to AI safety research. By simply subscribing, you'll help the great folks working on AI safety research, as well as the channel. Thank you for tuning in today, and please enjoy responsibly.